Welcome to math class. We have linear independent set, so you have to justify if the matrix is a linear independent. What we do is we write the 0, -8, 5, 0, so we add the 0 column, and then that will be -1, 5, -4, and the final one is 0, and there's 1, -3, 2, and 0. So that's we need to find the values of the x1, 2, and 3. So that one, we can see that we have to exchange row 1. So row 1, that's the sign double arrow for exchanging. So we're going to exchange row 1 with row 4. So row 4 becomes 1 is 1, 3, 2, 0. Then we have row 2, 3, -7, 4, 1, 0, -1, 5, -4, and 0. And then we have 0, which is our last one, 0, -8, 5, and 0. Okay, so that's our new matrix. The reason is equals to 0, we need to find the values of x1, 2, and 3. So we can see that row 1 and row 3, they can cancel it out, the pivotal position. So row 1 is 1, -3, 2, and 0, and row 2 is row 3, actually, -1, 5, -4, and 0. So adding row 1 and row 3, row 1 plus row 3, that gives us row 3. Okay, so that means we will add them, the difference, we put them in one of the rows, and the one is constant. So it's 0, 2, -2, and 0, that we put it on the row 3. Okay, on the next one, it's multiply that by 1, but you see 1 and 3, so we're going to say -3, so that the first pivotal positions will cancel. So -3 times row 1 will give us -3. -3 times -3 is +9. -3 times 2 is -6. 0 gives us 0. Times 0 gives us 0, and then row 2 we put it as it is, which is 3, -7, 4, and 0. And then we add them together. -3 times row 1 plus row 2 will give us the pivotal position cancels out, so that's our target. All that we put in row 2. So -3 plus 3 is 0, that gives us 2. -6 plus 4 is -2. 0 plus 0 is 0. And then from there we have okay, so we have to rewrite the entire we have to rewrite the matrix once again. So the first row, nothing changed, we write it as it is, 1, -3, 2, and 0. And then the row 2 is 0, 2, -2, and 0. Row 3 is 0, 2, -2, 0, and row 4, that's our 0, -8, 5, and 0. So that's our new matrix. So you can see that we have in the second row, third row, they're equal. So what we're going to do, we're going to say row 2 minus row 3, which will give us 0, entry in everything. So that we will put that in row 3. Okay, and then we're going to take row 3, exchange it with row 4. So we're doing two transactions at the same time. So it's negative, so give us -1, -3, 2, and 0, and row 2 remains as it is 0, 2, -2, and 0. And then the third one, remember fourth comes to third, so 0, -5, 0, -8, 5, 0, and the last one is 0, 0. So those are the transactions, that the changes that we made. And then from there we can see that we have that, so we can multiply by 4. So you can see that we can multiply 4 by row 2, actually a row 2, yeah, that's row 2, to give us 4 times 0 is 0, 4 times 2 is 8, it's 8 actually, yeah, 4 times 2 is 8, and then 4 times -2 is -8, and 4 times 0 is 0. And then we have row 3. So row 3 is going to be 0, -8, that's +5, and 0. And then we add them together for row 2 plus row 3. All of that all of that should give us row 3. So that's 0, that's 0, and that's -3 and 0. So -3 plus 0 is 0 plus 0 is 0. So that's we have, and that goes to row 3. So from row 3, row 3 there we have 1. I mean, the new matrix looks like 1, -3, 2, and 0. And then row 2 is 0, 2, -2, 0. And then we have that's row 3, which is 0, -8 is 0, -8, that's row 3. Yeah, row 3 has to be 0, 0, -3, and 0. Okay, and then the row 4 is all 0 entries. All the entries are 0, and that's what we have. And we have x1 there, then we have x2, x3, and that's a constant there. So those columns represent the different variables. So the last one is constant, which is 0, and from there we're going to say x1 is going to be 3. We take -3 to the right, 3x2 minus 2x3, and then x2 actually we have 2x2 is going to be 2x3, and then x2 is going to be x3. Divide both sides by 2. Okay, and that's there. So we have x2 value, x3 value. So all the variables are have representatives. So -a3 there. So we have negative x3 is equals to 0. So divide by -3, divide by -3, and dividing by -3 gives us x3 is equals to 0, and that's it. Now remember that we need to find if they're independent. So when we know that there is no free variables, so which means all the variables have values, so that means it's a sign for linear independence. So that means that it's the combination is not dependent. There's no combination of any to produce other results. So no free variables, and the matrix divided by the vector is going to give us 0. So ax is equals to 0, has trivial solution. So when it has trivial solutions, it means that it's linear. So that is linearly independent. So if there was any variable that was free, then in that situation it would be dependent according to the definition of linear independence and linear dependence. So the columns, they're linear independent. So that's our final answer. Thank you so much for watching, and don't forget to follow, subscribe, and it's Future Black.